This is the Amp Hour Podcast, recorded October 21st, 2015. Episode 272. An interview with Luke Beno of Analog.io.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
And I'm Luke Beno from Analog.io.
Hey, Luke.
Welcome, Luke.
Hey, guys. How you doing?
Well, we were talking out our arse last week about the Internet of Things, weren't we?
Yes.
I think everybody does that.
Right. And we've actually... So, Luke, apparently you know something about this sort of stuff. Tell us.
So a little bit about it. I run a service called Analog.io, and it was an entry in the Hackaday prize this year. Basically, it's kind of born out of a need that I had to...
Oh, hang on. I'm a judge in that. Should
He
I...
is.
No.
Should we not be fraternizing?
Oh, I think it's over. Yeah.
It's over for me. Yeah, I'm done.
Yeah.
So.
Oh, right. Okay, right. Fine.
You may not know
Okay,
it, but
sorry,
you didn't pick me.
Well,
that would be more like
your one, so
me.
it was like...
My round. Sorry.
No problem.
Ah, right.
I didn't see yours, so...
No hard feelings.
Okay.
Yeah, because there's sort of, people don't know, they're split between different judges this year, whereas before it's like the judges reviewed all of them, or at least all of them that came to the stage for the judges. But this year it's different. They only give each judge a little parcel of ones, so I didn't see yours. Sorry, Luke.
Okay. No worries. So, yeah.
All right, sorry, continue.
Yeah, no problem. So Analog.io is something that I created because I had a pretty big interest in logging information about beekeeping. And so as it started, I started to connect sensors to a beehive that my in-laws maintain. And then I kind of found a need for this online plotting tool and wanted to create a community where other people can share similar data that they've collected out there on the internet. So now there's probably about 630 people that become members of Analog.io, and they have interests like monitoring the pH level and temperature of an aquaponics tank, or there's a couple other beekeepers on the site, things like that.
How well their pot's growing, right?
Right.
Yeah, definitely.
And that's not pot plants, folks. Yeah.
Yeah.
My first question that immediately springs to mind is, why did you have to do that? Aren't there 20 million bazillion Internet of Things service companies that do this sort of stuff?
Yeah, that's a really good question. So I did it because I wanted to learn web programming. And it was just kind of a slippery slope that I kept going down, where I just created at first a plotting tool for myself, and it just grew into this, and I didn't really think about the other services.
Right, so it wasn't so much that the other sites couldn't do what you wanted, it's just that you went, that sounds fun, I'll do it myself.
Yeah, exactly. And, SparkFun has a server called data.sparkfun.com, and that's where I started. And that service actually doesn't have a plotting feature, so that's what I added.
Oh, boo. Yeah.
Right, so that was kind of a really essential feature. They didn't have it, so I created, at the time...
Well, what does their one do if it doesn't plot?
Right.
I mean, that's the whole idea of data.
Right. Can you walk us all the way down the stack, too? I mean, that's kind of the main thing that... So this is like we're looking at the output. The graph is the pretty output, but there's other pieces in there, right?
Yeah, there's a lot of other pieces. It can be really simple, like if you use a device like the electric amp or the particle boards, and so you have a sensor that's connected over, say, Wi-Fi, and it's pushing data over HTTP requests, and then that's stored on the data.sparkfun server, and then Analog.io just connects to that server, pulls the data records and plots them for you in an easy to use manner.
Oh, so you're not actually hosting the data, serving the data yourself. You're plugging into the SparkFun one.
Right, that's right. And actually, my goal is to connect to all of the different data servers. So right now, I only support the SparkFun server, but in the future, it would be sort of like the one front end that would connect to the Xively and ThingSpeak.
The new Amazon one? What about the new Amazon one?
Yeah, I think that's
Have you
also possible.
had a look at that?
I'm just starting to look at it now. Actually, that one is also more of a quote unquote backend tool.
Back end, right.
So
it doesn't have front end capability like doing graphs and stuff?
I'm not sure yet. I haven't gotten that far into looking at it, but my impression from reading some of the press releases was that it did not, that it was just the backend storage and messaging service.
Right. So is that kind of what SparkFun are doing with their one? Is that kind of what theirs is? Is it equivalent to like what Amazon are doing?
Yes and no. I think the SparkFun service is very much geared towards hobbyists, and it's more of an enabling tool for SparkFun hardware. I don't think that they're trying to take over the Internet of Things cloud services like Amazon is trying to do.
Got it. Yep.
Okay. So with the idea, so the idea would be, we were like we said, we talked about this last week. So if people are unsure what we're talking about, and you want to hear us talk more about what we don't know what we're talking about, you can hear last week's episode where we talked about the Amazon thing. But the way I understood it was, it would, if you use the back end Amazon thing, as far as I understood it, it would be like spinning up your own version of the SparkFun server in multiple locations, and then being able to service more and more devices over time, because it just keeps replicating and having more servers that can collect data. And then something like your service would then go into that singular point, which is actually a distributed point, but it looks like a singular point of data, and then you could pull the aggregated data from every device. Does that sound right?
I think that sounds right.
Okay.
Well done, Chris.
Yeah, I think that the Amazon service, from what I understand of it, it abstracts the concept of a server, right? So you just have an endpoint that you're connecting to, and it may be multiple machines or it may be just one. You don't really know, but you're just putting data into their service, and then just the same way that you can put data into it with a web address, you can pull it out using an API like a REST API, like every website has these days.
Yeah. Okay.
So, and I think the other thing is, the hardest thing about Internet of Things, or what term you want to use, is reliability, actually. So a lot of these servers, they go down quite frequently, and the problem is you don't know almost immediately if it happens. And for certain things, that can be, a problem.
Right, because if you've developed a widget that you've sold to 1 million customers, and the data goes down, and it goes down, and you're not aware of it, then those 1 million customers are not getting their data. Right.
They just say their device is broken, when in fact it just could be a layer in the whole piece could be broken.
And as we discussed last week, the other, that's probably number one, is server reliability. But I would have thought that would have been pretty much, taken care of these days. I mean, systems are like Amazon are pretty reliable, Generally speaking, even my lowly EEV blog stays up 99.99% of the time, It's, it's not too bad. But the other issue is longevity of service. Will it still be there in 5 years' time, 10 years' time?
Yeah, that's
will your widget
something.
still work in 10 years' time? And I've got a temperature logger here in my, I plugged it into the Internet of Things. It was using one of the big services, and it was only a year or two back, 2 years ago, and now it doesn't work anymore because that company's gone out of business, got bought, changed their protocol. I don't know. It just doesn't work. So that's a real concern for me. If I was developing an Internet of Things product long term that I was going to sell to customers.
Yeah, I 100% agree with that. Because if you don't plan your product properly too, you have a recurring expense of keeping those servers, keeping the lights on. And if you
Right.
only get one paycheck, there has to be some end of service. Otherwise, it'll start to cost you money, right? So,
Oh yeah, yeah. That's what's happening with the Wink. I think. I mean, the Wink is part of the Quirky. That was one of the products they did, and that's the only piece that's staying around is basically the Wink because, people bought these products and they expected.
But how long will that stay around?
Right.
as long as
You
they
know,
can
like
make money,
they're
right?
saying
Or-
it's staying around. Yeah,
exactly.
well,
Exactly.
Yeah, like in a year's time, it could be gone too.
How are people going to be making money here? I mean, like, is it all going to be in the hardware? I mean, like, you don't charge for your service, right?
Right. Yeah,
But,
that's right.
I mean, you could at
Have
some
you
point.
thought about a premium service? Yeah,
yeah.
okay, you
I'm
get
working.
these features for free, and then
I'm thinking about that, and I kind of have a prototype of hosted instances of server that are off from the main SparkFun server, and I'm testing that out to see whether or not it makes sense. And again, it's all about making sure then when you're taking money from someone to have a service that they feel like they're getting value from. So
yeah.
I'm
So
being
would that be hosted on your own server?
well. I don't have any servers. I just buy server
Oh,
space from
right.
DigitalOcean. So that
Got it.
yeah, I think that the cost of the VPS cloud is so cheap that there's no
It's
no,
becoming almost free.
Yeah.
it really is.
It's converging towards free. I mean, bandwidth is converging
I know.
towards
I
free.
know the book
Data
Dave's
is-
reading, so
Yeah, I
he's
know.
on this. He's on this kick right now. He's reading one of our past guest book, Chris Anderson. He's reading free, and of course, like a chump, I started reading again too. I'm like, oh, I got to keep up with Dave.
Yep.
I'll bet that
And
went to the
it's
queue.
it's entirely true. These
He's
things
right,
are
yeah.
becoming
Yeah.
free. Essentially.
Yeah, well, and it's that,
So if
that
you're trying to
freemium
build
service.
a business
so,
around it,
Yeah, you gotta-
if
you
you're
gotta have
trying
some
to build
other
a business
piece.
around that, you're going to go out of business. I mean, it's just you've got to find some other avenue
Right.
to do it. So
Right. And I think that there are certain services that people would find valuable enough that they would be willing to spend, a few dollars a month to keep them up and running. Like, for example, a lot of people use analog.io to monitor the temperature and humidity of a vacation home. So if you're trying to just, monitor your vacation home when you're not there to make sure that the furnace is working properly, I think that that's a service that people would be willing to spend a little bit of money on.
yeah,
So it's finding those types of applications that is where it becomes most important. But I would say most certainly the model has to be some kind of recurring payment that you make a profit off of the service, and then you need to have some type of hardware that's you shouldn't give it away, but it should be very low cost as a low barrier of entry to start using that service.
yeah.
agreed. One thing people will pay for is simplicity and ease of use.
Yes, I
People
agree.
will pay for that. People will pay not to have any hassle. I'll pay that. I hate hassle. I hate things that require, me to go learn something.
Right.
Spend days learning something just to get an Internet of Things thing running. I just want to plug it in and it works. I'll pay for that.
I think it's also about timing too, because you got to so if you sell Dave a vacation house, and then you say, oh well, you just bought this $500,000 vacation house because Dave's rich, and you,
But then
you
a
say
shed or something in Sydney. For Dave,
Yeah,
is that
well,
what
Yeah,
you
that's
said?
a
Sydney,
shed. Yeah.
no,
yeah.
his vacation house is in Cleveland. Come on, man.
Okay.
Yeah.
Well, my lab here is $250,000 for 50 square meters.
Yeah, there you go.
That's Sydney. There you go.
But okay, so anything in Sydney though, right? And then you say, oh, and for $3 a month, we'll make sure that your heat's always on, or that your office is going to be the right, like that kind of thing, where it's like,
Hell yes.
yeah,
Yeah.
of course, like who's going to say no at that point, Especially if you have that anchor, where you're like, oh, $250,000, $3 a month, it would take a lot of months to equal the cost out. So
Yeah, and also instead of selling to consumers, helping companies where they have servicemen that go out all the time, if they can have a low monthly cost to monitor something that they would normally send a service guy out for, the return on investment is pretty quick on
it's
something like
huge.
that.
Yeah.
So
Yeah. So let me ask a little bit about. So I'm looking at some of the. Me and Dave are both logged in right now, and well, obviously you are too, Luke. But we're looking at data streams, and people can sign up and log in and see a lot of these data streams because they're public. And but how far back can it go? Like, how much data do you store in this kind of thing?
Well, he doesn't store it.
I don't.
He
I don't
just grabs it.
Yeah, I don't store the data.
right.
SparkFun does. Their policy is that each stream is 50 megabyte rolling log. So as you add to the front,
rolling,
it goes
yeah.
off the back. And you have to push to it once every, I believe, 6 months. Otherwise, they'll, consider the data
right.
old.
A dormant account.
Yeah.
Right.
Okay. Oh, right.
Is there an option to see? That's where you can add value. Like your free service for this is only holds a 50 meg rolling buffer. But if you want to keep it forever,
Right.
You can pay your $10 a month and you get unlimited storage.
Mm-hmm.
Kind of thing, but that's not your end. That's I'm talking about the Spark funds and the Amazons, etc.
Right. So the other thing about the SparkFun service is that it's completely open source. So you can get your own SparkFun server running on a local machine, or you could spin up
Right.
your own VPS, and that could connect to analog.io as well. So if you're someone who wants to have the server within your own firewall, you can actually run that on a machine in your house. And then because the majority of analog.io software runs in client side in your browser, it can actually access data servers that are within your LAN as well.
Oh.
Right.
So
Nice.
if I wanted to make like a HVAC monitoring system for my house, right?
Mm-hmm.
I could have a server running on my like HTPC, my home theater computer, and then have it like show on the screen there, and then just basically. So then, what's the piece that talks to the analog.io part?
Well, the the server itself is written in Node.js, and it runs on the machine. It has a HTTP port built into the server that would connect to it. So you would basically need to tell me the IP address of that home theater PC, and then I would just do requests just like any other HTTP server would do.
So how would it get through the firewall though? Is it because it's running on my side?
It's inside the firewall, so yeah.
That doesn't mean much to us. Sorry.
Well, yeah, I'm trying to. I've run Node before, but it's not like
Right.
this,
Yeah.
so.
No, I've done zero.
I guess I can explain it quick. The so if you had a server running on your local network and it connects to your router, and then
This
your
is like
router connects
like
to
a SparkFun server. I'm sorry, like the SparkFun Open server thingy.
right, anything, even if you wanted to run a web server or anything. A good example is some of those really inexpensive webcam or network cameras. They're inside your LAN, and you go to like 192.168.1.4 and you get it. But if you went outside of your home, you could not access that IP address unless you did port forwarding in your router, right? And that your router is acting as a firewall. So
Got it.
So it's essentially the same thing, is that you could go to analog.io, type in that 192.168 IP address, and it can access things that are inside your firewall when you're inside your home. Then when you leave, it wouldn't be able to access it.
So what's the function that? So analog.io is pushing that node code down into my browser, and then it's all running the server within the browser. Is that the idea?
It runs the front end, so anything, the application itself is run inside your browser in JavaScript.
Gotcha.
Like
okay.
the tool that does the plotting, the tool that does all of the REST API requests to the server is all running in your browser. It's not running on a server.
Okay, that's kind of cool. So does that? So you mentioned that all the streams are public. Does that mean they're public by default, or no? I mean, like, because it requires determining where it is.
Everything is public by default. So because I don't give any guarantee of any form of privacy, I just have to default to offering all streams as public content.
Okay.
So I would say that if I wanted to create private streams, then there would need to be some extra level of robustness to guarantee that those are private, right? That puts
Which probably costs money, so therefore it'd be a paid service.
Yeah, right.
exactly. Yes.
Yep. Well, that sounds reasonable.
So
Now, the first thing that springs to my mind is what happens. Viewing all these graphs is all well and good. It's all funky. I love graphs, but what happens if I want to be alerted?
Yeah.
I want to be alerted when something goes over a threshold, for example, temperature. Oh, it's too hot. Send me an email.
So
How is that possible?
So it's not possible in analog.io right now because that would be a server-side function that would need to happen
Correct.
in real time. And so
Correct.
for that, you would
It
need...
has to be polled, yeah.
Right. So, I've thought about things like actually creating a monitoring service, but then I think that would be something that would need to be paid for. Either that
course,
or
yep.
some type of application that you run in the background, like a Google Chrome extension or something like that, that's constantly polling and monitoring that stream. But then it comes into the reliability of, is that service going to be reliable or not? And
Of course, yep.
it takes time to develop something that'd be reliable. So,
Well, ideally, the best place to do that would be on the data server itself, i.e. the Amazon or the SparkFun server, right? Doing it on your layer seems, or on the user's layer, as you said, like a Chrome plugin or something, that just seems 2 levels extracted in complexity.
yeah,
to me.
I completely agree with that.
Right.
The server is, it's always there. It's always on.
Correct.
You can count on it. That is the best place. And I'm fairly confident that is a service that Amazon would need to offer. They probably have it in their offering
they would.
already. Yeah.
Because they have to do the processing to get the data, to your little temperature sensor in your house is sending data to the Amazon server. The Amazon server has to store that. Well, at the same time it stores it, why doesn't it do a compare with some threshold you've set,
Right.
and bam.
Yep.
So, yeah, that is the place to do it. Anything else is just add in levels of complexity that can just fail. So,
And so the
Yep.
beauty of, the SparkFun service, which is actually called Phant, PHANT.io, is that, anyone...
what does that stand for?
It's
Fantio.
like an elephant. Like an elephant doesn't forget.
Fant?
Yeah, look at if you go to that, that's their logo too.
Right.
So, those features could be added to that code base, and then the whole community would benefit from someone adding those features. It's something that I've thought about, but everything lately for me is a decision on where to spend time, and that hasn't bubbled up to the top priority wise recently. So,
What is your highest priority at the moment?
well, I also have a day job, and
Yeah, that sucks, doesn't it?
yeah.
Luke's Patreon page can be found at.
So, no, but recently, I was competing pretty heavily in the Hackaday Prize in trying to do a lot of project updates there. So that was a focus for me for a while. And then, with a community that's growing to over 600 people, there's a fair amount of time just spent interacting with those people and making sure that, you're getting their feedback and making sure that the site is working for them. That's
Chris
my highest
wasn't
priority.
kidding about the Patreon thing. When you've got that many people, you should set up a Patreon page. Hey, help me, earn a living doing this sort of thing.
Yeah,
Maybe I will do that.
Yeah,
That would be
you
good.
should.
yeah. I mean, especially if this is valuable for people. So that's interesting.
Yeah. Ideally, my vision in the short term is, I'd like to see people using it as a medium to exchange data for a certain hobby that they're interested in, right? So if there's a aquaponics group out there that, everybody wants to collect pH information for their aquaponics and compare it against someone else who's doing the same thing, make a group of people in analog.io where, everybody's kind of collecting the same data and they can look at each other's and collaborate on that. And
Yeah.
I think it's fascinating to me to just see trends in, even just the temperature, the outdoor temperature over time. Just to see, today was a cold day or whatever, right? It maybe I'm alone, but I think
No, no,
that's
no. I'm just
interesting.
thinking we have this thing called going outside. I know most of us don't do it.
But it's not the same, Chris.
I know. No, you're right. It's data. It's charting. I mean, this stuff is actually really interesting. And so I come from the world of layering even more stuff on top of it, which I never even realized is kind of the big data but like SPC, like looking at statistical type stuff. That you could start to chart. Okay, like you said, temperature outside. And you could chart throughout the month of May. This is the average temperature. You got the mean and median and stuff like that. And then you could start to have banding and error bands, and you can tell when a day's an outlier. And you could do, I mean, like home science type stuff. I mean, granted, like I said, you could go outside and do this stuff, but having this kind of data and having it across locations and really starting to bundle it together can prove for some interesting stuff on the output.
Yeah, I agree, and I think that the nice thing is that when you're going outside, you're only getting one snapshot in time. When you're looking at a plot of a very slow changing data stream like temperature or things like that, you get to see that compressed, detailed view over many days, and that's interesting, right? So, like in the case of the beekeeping data, I'm monitoring currently the temperature at three different levels inside of the beehive, as well as the overall weight of the beehive. And so it's interesting because you can see the time of day that all of the bees are leaving the hive to go forage, and then at the end of the day, you can see them all come back with whatever they've gone out and retrieved nectar and whatnot, and you can see the weight of the hive increasing day over day, and then on certain days where maybe the weather isn't so nice, you can actually see that the bees don't leave the hive and they stay home, and that's apparent in the data. So from that perspective, I think it's pretty fascinating.
Have you seen that Australian Kickstarter for the beehive thing? I don't know what it's called.
Yeah, I forget what it's called. The beehive that the honey flows out the side of.
Yeah, the tap. It's on tap.
Yeah, it was very, very successful from
Hugely
a funding
successful.
perspective. But I think I'm just my in-laws are actually the beekeepers. I've been getting more involved with it, but I know within the beekeeping community that Kickstarter is kind of viewed as
Lowbrow.
sensational. Yeah, that's not quite
It's
how
the Holy Grail.
Right.
Yeah, that's not quite how honey extraction works, though. So
It's called honeyflow.com.
yeah.
What you're saying? It's like sacrilege, is it? Because real beekeepers, get their suit on, and none of this turning on the tap rubbish.
Well, you have to go into the hive and make sure that the colony is healthy.
Yeah.
There's a
especially
lot
with the
of
collapse stuff, right? All the stuff that's happening with bees these days.
right. There's a lot of things that can afflict a beehive that take a long time for them to recover. So beekeepers need to go into their hives and inspect them anyway. So it can't be as easy as just put a box
turn on
out
the
in your
tap.
yard and turn on the tap and get honey out
Right.
as they make it look. So
Right. Okay. Devil's in the detail.
yeah.
Right. That's like being like, I bought the Cowinator, and I have this box in the yard, and there's a cow inside, and then in 2 years I get a hamburger
Right.
or a steak. It's like, ooh, that's yeah. That's silly.
Oh goodness.
So, but
Sorry for that tangent, folks. So, who
that's
are your competitors in terms of like this visual? Because your one looks suspiciously like the one that I used to use, and I can't remember the name of the one I used to use. But like its graph is, it's almost like you're using the same code. You probably are. There's probably some
probably are.
standard graph plugin.
It's like
right?
libraries,
Yeah.
right?
yeah, there's
Right, yeah.
there's a graphing library called High Charts. You can actually see the link in the bottom right corner. So a lot of
right.
web graphing utilities are leverage that same library. The same
Right.
thing with the
So
overall.
do you pay for that? Is it free, open source? What?
It's open source as long as you have attribution and actually I think
Right.
too if you're not making money off of the use of it. So
Oh, okay. But if you make money from this, you have to then pay them some coin, do you?
a little bit.
Right.
It's fairly reasonable to license, but yes, it would cost something.
Okay. So your competitors, yes.
So other popular services that people use are a website called Zively, another one called ThingSpeak, and there's a couple other ones as well, and there's new ones that pop up every day.
Yeah, that's our concern.
Yeah, it's expanding market right now, definitely. But like take Zively for example. They are a company who started as a hobbyist enthusiast type thing, but then eventually they realized that they really need to go after business customers to grow their company and make money doing this. So
that I'm pretty sure that's actually the one I used, Zively, through this little temperature kit I've got. Yeah, it used Zively, but Zively were bought out or merged
they were
or
bought out
something,
by
and it just
Log Me In.
Yeah,
Yeah.
and it
Right.
yeah, and it just broke. I mean, my thing just stopped working one day. Wow. Thanks for that.
So Zively still exists and people
Right.
still definitely use it, but they have kind of shifted focus to more corporate type accounts. So there isn't as
Right.
much love being put towards the hobbyist community.
Because there's no money there, right? So the investors want return on their investment. So
Yeah, that's exactly
got to
it.
follow the money.
Yeah, that's exactly it. So with analog.io, I'm not chained by investment, so I can do things that I think are interesting or fun. So
I have to
like
do my
that.
best Yoda voice here. You will be. It might come to the day where you are. Yep.
Yes.
Yeah,
Yes,
exactly.
exactly.
Money.
Yes.
Right.
Have
Money-
to answer to
Money
investors.
changes everything, man.
Yeah, I know.
Sucks. Yeah.
So okay, so the idea though is like, do these other ones? Do they have the same kind of thing? So I see a lot of these like I'm looking at just like the analyzing and data like charting and stuff like that. But what is the ultimate output? Is it always to have that dashboard look, or is it to talk to other things? Like I think about like if this then that, like that's interesting as a layer in between hardware and other stuff. But is it always just supposed to be like looking at what's there, or do some of these guys, some of your competitors, do other things with the data at the back end, or at the end rather, not the back end?
Yeah, they'll be doing like Dave was talking about earlier, the threshold detection type thing. I think it's still emerging to have the cloud actually make decisions and actuate on it. That's not a mainstream application yet that I'm seeing at least from a from a consumer point of view.
But what does your consumer? But your consumer wants that event-driven stuff. Why does your consumer care about looking at charts and data? Most of them don't.
Right. When
They
something
want
goes
to
wrong,
be
maybe,
alerted.
right? I mean, like,
Yeah. They want to be alerted when something happens. That's basically the consumer world, isn't it?
Yeah, I agree, and it's not today. That's not something that I'm necessarily targeting. I think that there's probably other services that could service that better.
yeah, it's interesting. Some of these things, it also seems like it's. I mean, like you said, we're in the early days here, but some of it seems like when it's we think about localized examples, right? So like, and even I'm looking at thingspeak.com and looking at this, it's like, oh well, when your temperature and your humidity goes up above a certain point, turn off your humidifier and tweet about it and do these other things. It's like, we think about that and we're like, well, why don't you just run a wire?
Right. Yeah, or my humidifier has been doing that for my entire lifetime, and for the last 50 years or however long. So that's not a new concept, right? In fact, the latency and performance of that local system is actually much better. So yeah, there's a lot of throwing things at the wall and seeing what sticks right now. I think the other thing with Internet of Things is everyone is trying to make it into one concept, and the reality is that it's such a broad term. It means so much, it almost means nothing.
Yeah.
Right.
which is why I think everybody groans when they hear the term. And,
Yeah, exactly.
Yeah.
Yep, it's gotten to that point.
Yeah, but I think it's getting to the point of being useful too. Finally, I think.
Oh, true.
Yeah.
Yeah.
But you can still groan about it and use it.
Well, we sure do.
Yeah, there certainly
what
is a lot of
engineers do, isn't
marketing
it?
force, behind those three letters. So
Yes.
you'd be missing an opportunity if you don't, use them to your advantage.
It's almost a shame because, it's almost as if some big tech companies are expected by their investors to have a solution for the Internet of Things. Why don't you have it? You must have it. So I don't know what it is. Oh, I'll buy this company. Bingo!
Yeah.
I've got an Internet of Things.
Yeah, you're seeing a lot of thrashing like that, and personally, I think that there are big companies who don't understand it yet. At least my personal interpretation of it. So everybody has their own that they compare it against, but still a lot of experimentation with it. I would definitely say.
When I saw that IBM was getting into the space too, I was like, "Ooh, big blues here." There's a lot of word and a lot of money and a lot of buzzwords flying around here.
Yeah, IBM are in their death throes.
Yeah,
I'm afraid.
Right.
They're almost inconsequential these days.
It's their saving grace.
I wanted to mention as well. So I had mentioned imp.guru before. That's what it used to be,
right?
And you had sent me that little tiny sensor board, which is great because it plugged into the electric imp and it's super simple setup for that kind of stuff. What do you think? Okay, so people want to use Analog I/O. How do they get started? What's the easiest way? What platform do you suggest to getting started and getting stuff out there, just to do something simple?
Yeah, I certainly think that one of the best out of the box experiences is Electric Imp. It's easy to connect that device to Wi-Fi. Since you program it over Wi-Fi, there's no debugging cables or anything like that to use. And I have a tutorial for that temperature sensor that's basically, plug it in, copy and paste the code, and you're up and running, and you can read the code and see you can actually understand what it's doing in 10 lines of code or less, right? Yeah. So I think that that's a really, really good way to get started. Depending, maybe there's some lower cost ways of doing it, but I haven't found anything that's nearly as seamless as that. So
it's the imp. So you used to run imp.guru, and people presumably used that service. What happens to them? Imp.guru is now becoming Analog I/O.
Right. It's basically it's running the same thing, and you're still using the SparkFun backend. So all of those users, can transition over to Analog.io with the only pain is creating a login.
But they have to transition, so their device would stop working.
No, their device they don't have to do anything with their device because it still just pushes to the same SparkFun service. If SparkFun went away, then yes, they would have to change their device. Yeah. So it kind of uses that as the foundation to build upon.
So we're at the hardware level now. Well, sort of, kind of. But with the Electric Imp too, so the code. So if people haven't, I've done a little bit with it, and there's the device side code and the server side code. So that means the Electric Imp their servers are also involved. Is that correct?
Right. Yeah. They basically have a device that's running, and then they have a proprietary communication method between their device and their server, which they call the agent. And the server is just a very, very small bit of code running in the cloud. It's not like a full blown server like you would traditionally think of.
Yeah. So and so you're basically writing scripting code for both, right? So you're writing script for down on the actual Electric Imp piece of hardware, and that's that squirrel script stuff. Mm-hmm. And then there's an interpreter there. The amount of layers here is actually kind of mind-boggling.
Yeah.
To measure.
I would
this
recommend
stuff.
just not thinking about them.
Right.
But that's the thing. I mean, so people should also know Luke is a hardware guy. This is not this is Luke's interest, but he's a hardware guy. So you understand all these layers. So
right.
Come on, we got to get to that point at some point, right? This is a hardware show. We should talk about the hardware down to that level. So
Yeah, certainly. So
Why are there so many layers?
well, fundamentally, it's two things don't mix. It's the internet and low power microcontroller systems. So you can't take a $2 or a $1 microcontroller, run it off of a CR32 battery for 2 years, and push data straight to the internet with it. So there has to be some layers of hardware in order to do that. Electric amp, yeah, you can sleep it and wake up every 15 minutes and push off some data and go back to sleep. But I personally think that that's even overkill for a lot of applications. The other thing is with sensors, it's all about cost, because let's say that I want to spend $100 to instrument my house with sensors. Well, I could probably buy 2 Wi-Fi nodes for that price, but I could probably do 10 or more, low power microcontroller based systems with that hardware. So that's the other thing that I spend a lot of time on, is trying to figure out a solution that's easy to use. That's the key word. And also using these low power systems. So
you mean like ESP 8266 type stuff, or what? I mean, like when you say low cost type stuff, so you are also making some hardware to try and talk up to the other servers that then Analog IO talks to. Is that right?
Right. I'll add a couple more layers to the stack, right?
Well, actually, it sounds like you're removing them if you're not using electric imp, though. Or is that wrong?
Maybe. So I guess I'll run through one scenario that I've been playing around with recently. So I have a low power sensor node that's based on an MSP430 processor, and then it connects over. I use this off-brand Nordic Semiconductor NRF24 radio that transmits to. And I have lots of those nodes around. You can see on my Hackaday video, I did a demo with 16 of them all transmitting to a central hub that basically has that same radio, but then it takes those packets from the proprietary communication, puts them on the Wi-Fi, and then from there they go to the cloud.
Okay, so that's like a hub and spoke where you have a centralized sensor receiver, basically, and then that translates to the web stuff.
Exactly. So ESP8266 could reside in that hub, and that would be one pretty nice solution from a cost perspective. There are some really big advantages to having the electric imp layer in between, because even ESP8266 is not going to be exceptional at doing all of the HTTP requests and things like that to connect to the server. It's way more convenient to use some of the libraries that are built into the imp.
Okay, so
and the other thing too is that like we were talking before, my sensor network is 100 miles away from my home. So if I want to write code for it with electric imp, I can actually sit at my desk 100 miles away and develop code for it, and push updates to it without needing to be there. Or, for example, needing to be in a bee suit, standing next to a beehive, writing code. Yeah. So
I'll plug in my pick programmer. Let's open this beehive, suit up.
Right, you got to put the smoke in there, right? I've seen that for beekeepers.
Plug in your ISP programmer.
Yeah. So it's definitely something that I've done, but not something that I like to do frequently. So that is a nice thing.
Yeah, but it makes you check your code better.
No, it doesn't. Yeah, when you want to write code quickly, it never ends well.
Yeah. No, that's a good point though about the dynamic, rewriting code, stuff like that. That does make things really convenient. I
thought that was the holy grail. That was the whole idea of the Internet of Things, is that these things are connected to the internet and you can do anything with them from anywhere in the world, be it getting the data or reprogramming them or rebooting them, doing whatever. Mm-hmm. I thought that was the whole holy grail concept.
Yeah, it is the holy grail, and we're not there yet, but there are certain solutions that that are working towards that. Again, I go back to though it's all about those low cost nodes at the end that are, so important, because like I said, Wi-Fi isn't going to work for those solutions, and it's arguable whether or not Bluetooth Low Energy would work for those systems. So
just because of the distance or power or what?
Distance and in proximity to a phone. So, in the case of the Beehive, Bluetooth Low Energy doesn't really buy you anything, because the value that system has is when you're not around. So your phone isn't there. What good is Bluetooth if you're not within proximity of the device?
Right. Yeah, that's a good point.
So there are, like for example, Google released a wireless router that has some of these low power RF networks built into it. And I'm hoping that
so you don't need your phone. You can it just works like Wi-Fi, right?
Right. Yeah, a low power, low bandwidth version of Wi-Fi. So
it has to be built into the router, because the router is the internet hub of every home, every location, isn't it? It's, you've got to have it.
Yeah, I think that
otherwise
it's I think that's a big piece, and it's just starting to happen now, and it's definitely not mainstream. So the problem is that when it goes into a solution like that, it drives a really complicated protocol, something like Thread or that IP over RF. But it needs to be really simple and something that doesn't require this huge software library, and it should run on, a couple K of code on these embedded devices so that they can cost $3 and work. I think
right.
that's and work and do that at low volume, like 100 pieces as opposed to 100,000 pieces, and that's when you'll really see a lot of things come online, I think.
Yeah. Well, so like this is almost like a reimagining of like server and thin client type stuff, except now the thin client is so thin it can barely power itself, right? I mean, it's just spitting. I mean, like, so like when we talk about the sensor, like the one you made, I'm sorry I didn't see the one that you made, but like the idea is it's just waking up, spitting data, going to sleep, right? Waking up data, and it's stupid. It doesn't know. Does it even know if the data has been received?
No.
Yeah, I mean, like, and that's kind of almost what you have to do, because then you have to versus transmitting versus receiving type of thing, and the amount of code you need, like, that's kind of crazy.
Yeah, it's like it would be ideal if I could just wake up, shout something, have a router collect it, push it off to the internet, and then that's the end of it, right? And if, in the case of temperature and humidity, well, if I miss a sample or two or even 10, it's not the end of the world. Those are the kind of systems that I like to work on, because then there's it's not so high stakes.
Yeah, this actually all kind of parallels another job I've had with distributed control systems when I was working on, and they did all this stuff except they just didn't trust any of the wireless stuff. So it was wires to everything, but still it was about passing. When you're passing a pressure sensor from like on a 4 to 20 pressure sensor that has a 4 to 20 milliamp output, you can program it, you can tell what's in an error, but like it's a dumb node. It's just spitting data. You need some kind of intelligent controller that then handles that, reacts to that, maybe actuates something else, and then can still talk to the network and get new code and stuff like that.
Well, is the Internet of Things destined to be a one-way type thing? Is that going to be the majority of applications where data is pushed out rather than, interacting with stuff?
I think that there's going to be a pretty decent percentage of those nodes that are exactly that. I don't know what the number is, but, when I think of applications, I can think of a whole lot of them that are just monitoring a one-way link that are monitoring certain things, right?
Yeah, and local processing is everything, right? If you want to do something locally, you do it locally. You don't spit it out to the Internet of Things cloud and then do the processing in the cloud and then spit it back to your device.
Right.
I mean, that's just
adding
layers for the sake of layers.
Right.
But I think that's how people do it right now, right? They're like even with, I mean, with wireless, it makes it kind of weird where the line of demarcation is. But like, when you think about if you go into your house and your foot crosses through a laser tripwire type thing, right? And then it goes and that says, okay, the line's high. We're going to send it to the cloud, and it processes it, and it says, Dave's in the room now, or Luke's in the room now. And then it sends a thing back all the way down through those layers that says, turn on a light.
Yeah, that's just... Yeah, it's stupid.
It's stupid, right? Like you said, it should be laser trip, if laser trip, then light, and it's all on the same controller, right? I mean, that's...
Yeah.
And then later, if you want to rewrite the code for that, like if laser trip, wait 50 seconds.
And then if you want to be able to monitor that from the cloud because it's the Internet of Things, okay, you can monitor it, but that's not where the processing should be.
Right. You know? Yeah, I agree with that. And I mean, that specific example is like not exactly one of the biggest problems that that I have in my life right now. But there are
a lot of laser trips.
There are a lot of manual processes that we do that are really easy, but could still benefit from the Internet of Things. And a lot of it is, I mean, just think about like people who heat their homes with propane tanks, and they want to, are you going to go out in the freezing cold? Because I live in Wisconsin where it gets cold. Go out there and read the gauge, right, to see if you're if you need to order more propane or not, versus log into analog.io and see well, this is how much propane I had 2 weeks ago, and this is how much the slope of how it's going down, and you can kind of interpolate in your mind, I need to order this by next week, otherwise I might run out.
Right.
Sure, but that's a simple data presentation issue, a data collection issue. Why does that have to go to the internet? Why does that have to be an internet thing? Why can't you just have a little display inside your home and a wireless, a local wireless thing that just connects to a sensor out in your propane tank?
So I think the question back, Dave, is which one is simpler? You can, but which one is easier?
The local one. Well, it depends on the platforms you've got. It depends on the devices and modules and tools you've got to implement it.
Mm-hmm.
But ultimately, the local solution has to be the easiest. It has to be.
You're thinking like the light switch type?
Yeah, it's got to be easier.
So take the propane tank example.
Right.
So you have one device that goes out on the tank and measures the sensor. And then you'd have another device in your home that would show this graph dedicated, and when you wanted to check it, you just walk over to it. Is that?
Yeah, like it sits in your kitchen, for example. Like in our kitchen, we have like an indoor-outdoor thermometer thing. So it's got one of those wireless thermometers. So the wife is paranoid about, what temperature it is today, so I know what layers of clothes to put on, right? She just looks at as she's in the kitchen. It's the hub of where she, where we live, and there it is. It's displayed. There's the outside temperature. None of this Internet of Things rubbish. It's just like a little cheap wireless sensor. Has its own protocol. It just works. It gets a couple of years battery life.
So I guess, and I completely agree with that. The counterpoint is when you get 10 of those little sensors that are monitoring all kinds of different things in the home, you kind of get this whole remote control.
You need a control.
Yeah, like when you have a home entertainment system with 10 remote controls.
Yeah. Sure, but it's still easier to do it. By definition, it is easier and simpler to do it locally, though. Surely.
I'm sorry, but
what happens if your internet connection goes down?
Then you would have a problem.
You've lost all your sensors. You're screwed, right? You can't even measure something that's just out in your backyard. That's just dumb, right? It's So therefore, that's what I'm saying. By definition, it's more complicated, being an Internet of Things service.
Right, but I think...
I'm not saying it's better or worse. I'm just saying by definition it is
I think part of the problem here is, though, that we are using simple examples for the sake of being simple, right? And like Luke's saying, it's not it's not the simple stuff. It's when it starts to expand out, when you when you're a service provider now. I guess maybe that's a better place to look at it, too. Say you're a service provider, and you're willing to give people discounts on their propane tank if they have these tools in there, because then it makes your monitoring easier because you're monitoring 50,000 homes at once, type of thing. Mm-hmm. I mean, I again,
Oh yeah, that's a whole different.
Yeah,
that's a whole different level.
Yeah. But I think that's where the money is too, right?
Yeah. So,
Like-
so there's no hard and fast rule. I guess that there's no one magic solution, but it, I think that in the long run, as those sensor devices become cheaper, you will find a situation where this connecting to the cloud solution will be a lower upfront cost, and if more and more things become connected, it's really just preventing the number of devices that you have in your home that are cluttering up things, right? Because everybody carries one universal monitor, which is their cell phone. That's
right.
Phone, right?
Yep.
So
Yep,
it's
that's
virtualization of those dedicated displays onto a web browser or onto a mobile phone or something like that.
Here's one thing that just popped into my head, and I don't know why, but it could be important, right? If the whole world goes Internet of Things, everything's connected, everybody's light bulb is connected, right? So that they can, no matter where they are in the world, they can see if they left their light turned on, and if they did, well, they can switch it off. Fantastic, right? We're living in the Jetsons age, right?
Or Back to the Future.
And-
Well, come on, man.
Well, it is back to yes, it
we are
is
living
today,
in the
isn't
future.
it?
We should at least make
It
a
is,
mention of it, right?
it is today. Is it well?
Yeah, I know.
Yesterday here in Australia was the 21st of October, but I believe it's still the 21st there, is it not?
It is. Yep. October 21st,
Anyway,
2015.
Yes, it's Back to the Future Day. Fantastic. So we now live in a world where the Back to the Future was yesterday. Is the past. Yep, that's scary. Anyway, what was I saying? Yes, when if everyone's got this, and we're talking scale, right? When you've got hundreds of millions of people, 1 billion people, all with their internet-connected freaking light bulb and every other sensor, right, in their home, what does that do to the amount of power we're consuming? Sure, you could, where does, you have to look at the data, right? But no, that's a big deal. I don't want to live people, we're trying as a society, to minimize our power usage, right? It's a good thing, with all sorts of, the Energy Star compliant, things that draw less than a watt when they shut down and blah, blah, blah.
I don't think,
right?
I think
if
that's
everyone keeps adding sensors to everything,
no, you're barking the
wouldn't
wrong
that
tree
use
there.
more power just for the convenience?
No, I think you're barking the wrong tree there.
Why?
Because
Yeah,
these are
why?
not designed to be high power. I mean, these are low power sensors, right? I mean, these are all.
Well, but
but
Chris,
when you have 100 of them in your home,
we're getting away without having them today. So even if they can consume a nanowatt on scale, that it would be more power, right?
Because everything
exactly.
is dropping in general, anyways, right? Do you guys run any desktop computer? I mean, I'm running one in my lab, but do you run desktop computers in your house? Even that, not having a desktop computer versus having a laptop, you're burning way less energy, just because it's the not always on thing. Everything's designed to be mobile. Everything's designed to be handheld and battery powered. It's just the trend is going down. I know that there's more devices, but
it is. But the numbers of devices permanently on and connected is going up. That's what I'm saying.
yes, but I don't think that this stuff is actually permanently connected. That's the thing. These are all designed to be low power, shut off. I understand what you're saying, but I'm playing devil's advocate because I think I actually can, and I think I'm right here.
No, but the whole definition of these things is that they're always waking up 24/7. Wake up, send data. Wake up, send data. Wake up, send data. Everything. And if you've got 100 of them in your home,
Let's defer to
could be
Luke
a
on
lot
this.
of-
Luke, tell us the answer. What's the real thing here? Come on.
Well, I don't like the analogy of the connected light switch. Personally, I'm a pretty early adopter of technology, but I'm with Dave on that particular one. I am perfectly okay, going over to the light switch, flipping it on, and that's a great, simple, elegant solution.
Oh, I'm there too. Don't get me wrong on that stuff.
Yeah, so I think the efficiencies that we get from connecting sensors are to prevent mistakes that otherwise cost us a lot of money and energy. So
right.
in the instance of, let's say, water monitoring, and I've personally suffered this myself, right? If you could actually detect a leak in your home before it becomes a really bad situation, and the Internet of Things helped you with that, the the net gain on the
then
environment.
it's worth it. Your payback is, your payback makes it worth it.
Right. So, but I don't like technology for technology's sake. So
Right.
there's a lot of shades.
That's what I'm talking about. Yeah.
A lot of shades in between. But the nice thing is that consumers are efficient in that way, and that they'll buy solutions that they get value from. And so I think that some of the connected light bulbs are struggling to get traction because consumers are telling those companies that no, we're really not that interested in a connected light bulb.
Yeah. It's a toy. It's pointless.
Right.
It's,
Yeah, I agree with that.
Yeah.
And so
Right.
who knows? Maybe there are applications that you would think would be technology for technology's sake, and they actually turn out to be killer. I can't think of any examples off the top of my head, but that's the kind of things that people are experimenting right now, and I think that it's good.
Yeah. Can we go back to the hardware real quick for a little bit? That stuff that you designed. So could you, like, a packet that you would send out of this sensor node, right? So you have a temperature. Is it a temperature sensor on the MSP430 board?
Yeah.
Okay. So, like, what does that packet look like? I mean, is it just here's my temperature, here's my ID, or
just here's my ID and this is the raw binary of my temperature? There's nothing more to it than that.
Okay. And so that squirts through the NRF24 off-brand radio like you're talking about.
Yeah.
And then that lands on what?
On that hub device that has that same radio, plus then it bridges over to a Wi-Fi connection.
Via like a module?
ESP8266 or Electric Imp are the two that I've used so far.
Okay, so ESP8266, great. So what does it actually do the numbers conversion in the hub?
Yeah, I actually do it in the node, just because it's easier to do there from a coding perspective. I'm actually kind of allergic to code, so I try to write as little of it as possible.
Okay.
So I'll do it.
I'm sorry, that's funny because you're running a website.
It's efficiency. It's efficiency.
Yeah, it's a necessary evil, right? I would much prefer to spin boards and solder chips to boards all day, but at the end of the day, you have to be really, really proficient at software to make, world-class things.
Yeah.
That's just how it is right now.
Yep, true.
Oh, me and Dave are learning that one. Don't worry about that.
No, yeah.
Okay, so
what? Hang on. Why? So you're using this two-step RF process. It goes through this proprietary kind of thing, and then it goes to another node, which then transmits via Wi-Fi.
Mm-hmm.
Why not just put Wi-Fi on the node?
Cost and power. Mostly
and
power now.
Right.
Okay.
Right.
Yeah, that makes sense.
But overall, it's using more power, right? Because you're running two separate RF solutions. So I'm talking about overall system power is bigger.
Yeah, slightly.
But you're forced into that because you can't battery power the node with Wi-Fi, right?
Correct.
So
correct.
Yeah. So if that keeps dropping in power and cost, then you'd be that, and that might be the end goal, right?
Yeah.
I think that's why a lot of people.
If you had, so if you had 20 of the nodes let's say that all of those nodes were Wi-Fi, that solution would be in aggregate higher power than having 20 of the low power RF nodes and one high power RF node.
Correct.
Or Wi-Fi node.
Yep.
Yeah.
It's a system engineering
Yeah,
problem.
that's a good one actually.
And then the other thing is that you can wall power the hub, and you can also do things on the hub side to increase the range by having a more power intensive but more sensitive low noise amplifier on that hub, or a power amplifier that can bridge the distance further. So those are all things that you can do.
Or you could even plug it into Ethernet, like totally
Yeah, you
crazy.
could plug it into Ethernet too. But I don't know about you, but most Ethernet ports in my house are like in my basement, which isn't a convenient place.
Where do you spend all your time, man? Come on.
I'm fortunate enough to have an attic for my home office. So.
Oh, okay. Okay, so let's keep following the packet. So now the packet's in this hub thingy. It gets translated, then it gets pushed through the Wi-Fi to the SparkFun server. Is that right?
Right.
No, it goes to the router.
Well, okay.
The router is a pretty
come
transparent
on.
layer, but
Yeah.
Yeah,
Right.
that's true. You should mention it. You're right. Okay, then it goes up to SparkFun, gets stored in the SparkFun server as the data. So at 1:23 p.m. today, the temperature in my living room was 54 degrees Celsius or Fahrenheit because it's freezing, or really hot if it's Celsius. And then Analog IO then goes, when someone accesses Analog IO, then that goes and reads from the data stream
Right.
off
Yep.
the SparkFun server.
Yep, that's the whole stack. Yeah.
So you said, though, that it was... So this is what I'm trying to get to, sorry. You said it's more complicated when you're spinning your own thing like this versus using Electric Imp. What piece would be different if you were using Electric Imp in that process?
Well, it's just from a coding perspective. Just the high level code and the libraries that are afforded by Electric Imp versus writing some of those requests for ESP8266. It's just easier to use. That's
Okay.
That's
And
a
so-
simplification. It's a higher level of abstraction, which makes it easier to use, but adds complication. But when you abstract
Yeah.
things, you're adding to the stack, but you're making it easier to use from the user's perspective.
Right.
Now, does Analog IO only request data from the SparkFun server when somebody's viewing that web page?
Yes.
Right, it does.
Yes.
Okay. So if a million people log into that one page on analog.io, then that gets a million requests from SparkFun.
Yeah. And that's
Each one's an individual connection, so it doesn't
That's right. There's no
Right.
caching or arbitration.
cache in. But
Yeah, and I think that's some of the scale problems that, like, say, Amazon and Microsoft are addressing, is how do you deal with those types of inrushes of packet content. That's something that would bring the SparkFun server probably to its knees. But other more enterprise grade things, they're thinking about all those types of scale problems, which will become really real.
Yeah, I think you can even think about it like Twitter like that. When you think about if each person is a sensor node, right, or each tweet is a sensor reading, then you think about that's all stored centrally, but then that's all distributed as well, and then other people are reading it, and like it gets pretty complicated. Like I always thought, like, why is Twitter so? Why does it go down? Why is it hard to do that kind of thing? But then you look at the scale and just like how much traffic's going through there.
Yeah, it's immense.
And that kind of it approximates craziness. I mean, like,
So does your server could potentially have exactly the same issue if a million people started requesting from your website? I mean,
it would. It certainly would
it's-
not.
yeah,
We would not
same
survive
problem.
that sort of inrush of traffic. I don't think so. At least,
right?
it's not something that I've ever tested. I guess one other thing that I think is kind of interesting to talk about too is this concept of MQTT.
oh yeah, I
Yes.
saw a great presentation about that stuff. Yeah.
Yeah, so it is actually very, very cool because when you send things over MQTT, it basically
Which is what for those who don't know.
so it's two things. You can think of it as a lightweight protocol that devices can communicate to what they call a broker, which is essentially the same thing as a server. But I kind of equate it to, like, think about satellite communication. The nice thing about a satellite is that it's way up in space, and in Australia you can ping the satellite and then it will reflect back to the United States, and you can make really long range communication using that satellite. MQTT is kind of the same thing, where I think of this MQTT broker as a satellite up in space. Dave, you transmit a packet to that broker, and if Chris is subscribed to it, he can get that packet back anytime that you transmit it. So it's a publish subscribe protocol. But what's interesting about it is that pretty much anything can connect to it. So say you have an ESP8266, you transmit a packet over MQTT to a broker. You can have JavaScript running in the browser or on a mobile phone that can subscribe to that and get it. So it's really a pretty transparent way to get data from a device to another device in real time.
So it almost like shortcuts the. So like Dave says, he wants to get notifications. It shortcuts like the storage and then monitoring and then retransmitting a notification that, okay, now it was 70 degrees in here. Now it's 71. It crossed that threshold. Now it's just Dave's always getting each packet each time on his mobile phone. It's 70. It's 68. It's 69. It's 70. It's 71. Then his phone can tell, oh, now it's 71, and I can just beep for Dave. Is that the idea?
Yes.
But I don't want that because then that's using my bandwidth that I'm paying for. Screw that.
Well, but no, because then you can also.
If I'm being constantly push data to my phone.
Well, you can have either, if you subscribe. If you're interested in subscribe to it, that would be one. But there are a lot of things where you want to have like, how do you build real time messaging into like say a web application? MQTT is an excellent way to do that based on the libraries that exist. So,
right.
Just with, like I said, I'm allergic to code. I lose interest after like 10 lines. So you can definitely do this in 10 lines of code, which is pretty impressive, right? So it's easy to use, I guess you would say.
That is really interesting. And I think the Amazon one said, so that part of the thing, they said that like in terms of incoming data, they'd be able to subscribe to MQTT packets and then also HTTP 1.0, I think they said. So that would be like sensors can spit out these two types of data, at least right now, and it'll accept it and then start crunching on it, whatever.
Right. So I think you'll see that become more and more prevalent. That's going to be very, very popular technology for Internet of Things. So the day when I can transmit a low power RF signal to a router, have it bridge over to an MQTT signal, and then anyone in the world can subscribe to that, that's kind of the day when you see this convergence happen, in my opinion.
Huh.
I think, as we mentioned before, I think the big deal there is the router.
Yeah.
The router getting other connectivity options apart from Wi-Fi. I think that is going to be the next killer thing.
I echo
because
that
I don't want to have
completely.
to add extra layers. I don't want an extra thing then I've got to plug into the PowerPoint and then maintain it so that in your case, those low power RF, the proprietary low power RF thing, I want that to talk directly to the router because the router's always plugged in. I have to. It's my internet hub. I don't want to have another thing which is then plugged into a PowerPoint which then translates that into Wi-Fi and then transmits that to the router.
Yeah.
That's just...
It's silly,
no.
and that's the pain that you'll have to go through until that happens. And if people from the router companies are listening to this, I'm sure they're working on it already.
Google have started it, right?
Yeah,
Google
SmartThings has got bought by Samsung. That's what they started with, was to be that centralized router as well.
Yeah, and the other thing that's happening now is something called LoRa, LORA. And that's basically the router, but more of it's a router that gets 7-mile radius of low power RF communication. So you can actually deploy 5 LoRa hubs in a community, and the whole area is blanketed with this coverage.
Wow.
So it's gaining a lot of traction, and there's actually a Kickstarter now called the Things Network, or it's going to be happening soon, that, they have these routers that they're like $200 and you can, put one in your home and service, let's just say a 5-mile radius of low power RF nodes. So that's a pretty, I'm watching that to see what happens. It's like a low power cell network.
Yeah. Or like running like a APRS net type of thing for...
Yeah, an APRS,
APRS,
I wish that I knew more about it because it's really interesting. And that's been around for a long time, but that's like a very visionary thing for what the future looks like, I think. It just, making that more mainstream.
So one last thing. So you walked us up through the packet and stuff like that. Can you just quickly tell us on each of those pieces on your project? So you mentioned you hate code, but what code was written on each piece? Sorry, what language was running on each piece there?
So for the MSP 430, I like to use Energia, which is the Arduino port for MSP430. So
No.
I write it there.
Haven't heard of that.
Yeah, it's basically Arduino IDE for TI MSP for all of the TI parts. So it's pretty cool. And I'd be missed if I didn't put in a plug for 430.com. OH 430oh.com. It's a great community for talking about those projects. It's very project oriented. But yeah, so I use that, and then for the hub, if I'm doing ESP8266, I like to just use the Arduino package for that. If I'm doing electric imp, I do that. And then from there, the analog.io backend that does like the user login and stores your account information, that's written in Ruby on Rails. And then most of the web application is written in JavaScript with a framework called AngularJS. And so that's all the different coding stuff that's done there.
Yeah, no, that's good. That's about what I expected.
I don't know most of those.
What was the one? What was running? Ruby was on which one? On the.
It's the server that's storing all of the analog.io user accounts and information about your profile and things like that. Just all of the.
Gotcha, like the backend stuff for the.
Right, for the service itself. That's not running in. That's independent of SparkFun. So
right, and SparkFun. Do you know what that's written?
It's all written in Node.js.
Okay, and that's the font.io or whatever.
Yeah.
Okay.
Yep. So,
man, that's a lot of software.
It's a lot of stuff, right? So, if you do become educated in this area, though, I think that there's a huge career opportunity for you long term, just because there are not a lot of people who understand the full stack, right? So that's going to be a critical skill for people who are just starting out. I'd highly recommend developing those skills.
Right, and I mean you could replace a lot of this stuff, right? That MSP could have been in C, and like you could have written some stuff in C or some in Java or whatever you wanted to do.
I'm always going to pick the easiest thing to use that has the highest level of abstraction, because I just don't have time to be mired in the details of doing something lower level.
With this many layers, it's like you have to almost.
Yeah, you really do. So
that's why people use IMP, right?
Yeah,
that's
Yeah. It's very important because you can write the same number of lines always, but you can do more with less. Do it. That's my policy. So, So I guess then the other thing that kind of a shame if we didn't touch on it was, Dave, I have an answer for you on a long-standing question that you've had about
excellent
high-density FPGAs that don't have a lot of I/O.
Oh, right. In the there's a couple out now, isn't there? There's but it's taken like 20 years. So
right, and I can explain why. So
please do.
So I guess the other part is in my day job, I'm an ASIC architect for Triad Semiconductor, so I understand the fab process. The problem is that when you're designing a chip, you're either core limited or pad limited, meaning that those logic elements inside the die itself dominate the die area, or the pads do. So in the case of an FPGA that has a lot of resources inside of it, that would be a core limited design. So they put the pads there because they kind of, not to say they come free, but they kind of along for the ride with the core. So and then at that,
but you don't have to bloody well hook them up.
That's true. So it becomes a packaging type thing.
Right, issue. Yeah, that's right.
I think maybe they just couldn't hold themselves back from packaging a device.
I know.
Get all these pads. Come on, guys. What are we gonna do with them? Get a BGA. Come on.
Yeah.
So I mean, there is a limitation. So I don't know what those die sizes are, but of what size die you can put in a particular package. So as the process node shrinks, the overall die size goes down to fit actually in some of the smaller packages. But that at the end of the day, I think is kind of why that exists.
Well, I've spoken to many of them, like many times over the years, to Xilinx and Altera, and they keep saying the same thing. It's because there's no demand for it. Our customers demand
Dave,
these 1,000-pin freaking
They're
packages.
saying
in these
Dave,
large...
you don't matter. Sorry, man.
Yeah, exactly. I know. And even when I work for the big companies, they say, "Well, no, sorry."
Relative to the demand for the higher pin count, yeah.
Yeah, it's they're just saying people who want the real high density, stuff like the $100 FPGA or
or
even
more.
$1,000 FPGA, they want I/O to go along with it. That's just
just in case.
So yeah, it's just the way it is.
But now with process nodes shrinking, you are getting to the point where you might become pad limited because pads don't shrink nearly as fast as transistors shrink in Moore's law.
Oh no. So anyway, but there are a few on the market now. They seem to be, they've gone, "Ooh, we think there's a niche here now." And yep.
I think it was
so you can
more
actually
the process technology caught up, but maybe some.
Right. Well,
maybe they heard Dave. Who knows?
I don't think so. I think they could always do it. But yeah.
Dave got more subscribers, so maybe we should listen.
He does have
Don't
a
follow
pretty
that
big
trap, folks.
Correlation there. All right. Correlation equals causation.
That's right, yeah.
Yep. Yeah, I'm responsible. Yes. No. All right. Well, thank you very much, Luke, for setting us straight on Internet of Things.
Well,
because we just don't know anything.
Maybe we just created a little bit more confusion, but
it's so many layers, man.
I know.
But I do appreciate the amp hour, and Dave, your video blog. It really did actually cause me to get off my butt and do some things in my spare time. So
awesome. That's what I want to hear. Thank you.
I was just looking back. It's been like actually, I think, over 5 years since I've been watching EV blogs. So it's crazy to think of all the changes that have gone on in that time. So it's a pretty huge accomplishment for you guys.
And where can people follow you, find you? Are you a Twitter man?
Well, you can follow me on Twitter at analog_IO. Also, I document all of my work on Hackaday, on the Hackaday project. Hackaday.io, I guess you'd call it. A lot of IOs recently.
Yeah.
But
whatever happened to .com?
Dude, everybody used up all the .coms, so
analog.com's been taken for a while.
Moved on to new territory. Which, by the way, just kidding.
What, you're gonna buy analog, not Maxim? Is that right?
Yeah, I'm saving up my pennies.
Okay.
Did you hear how somebody bought Google.com?
I did, yeah.
For like a day?
Yeah.
Really?
Yeah, that was
I thought it was a minute.
Awesome.
I thought it was like really, really short.
I don't know, something like that. Yeah. Anyway, that was great.
And then the trademark lawsuit came out.
Yeah, right.
Yeah.
Well, that's awesome. And so I think people should definitely at least, sign up. You can see other people's streams. You don't have to start streaming immediately. You could sign up. You can be part of the community, see other people's streams and kind of see what it's all about, and then follow the tutorials, stuff like that, and get your thing connected to the internet.
Totally.
Awesome. Thanks, Luke.
Very good. Thank you, guys.
All right. We'll see you.
See ya.
Bye.